From Physical Science with Vernier, we're going to do experiment number 40, which is falling objects. In this lab, what we do is drop two different objects. One is a coffee filter, the other is a textbook. If we were to drop these in a vacuum, they'd fall at the same rate. But because of the effects of air resistance, they're going to drop at different rates, and we're going to investigate whether or not they reach terminal velocity and how air resistance affects these two objects that have different weights and different shapes and sizes. To take the measurements, we're going to use the motion detector, which I'm going to connect into my LabQuest interface, which is already connected to the computer. As soon as we open Logger Pro, it detects that there's a motion detector attached to the computer and sets itself up for a graph of position and velocity versus time. But since we're doing a specific experiment, I'm going to go into the File menu, choose Open, go into the Physical Science with Vernier folder, and scroll down to experiment number 40, which is this one, Falling Objects. And when I choose Open, now I get a new graph of position versus time that has slightly different scaling that's tailored specifically to this lab. So now I just hold the coffee filter in front of the motion detector, and I want to make sure that when I drop it that it's going to fall straight down so the motion detector sees it through the entire fall. So once I'm ready, I reach over and I hit collect, and then as soon as the motion detector starts ticking, I go ahead and drop it. And I see that I get a graph of position versus time and velocity versus time drawn in real time while the object is still in motion. So now what I'm going to do is store that run. To do that, I go into the experiment menu and choose Store Latest Run, and you'll notice that that will turn the graph trace from a thick line to a thin line, indicating that it's no longer the latest run. So now that we have the first run stored, we're going to go ahead and drop our second object, which in this case is a textbook. And I've done a couple things to make sure we get clean data with a textbook. I've got it taped shut so that when it hits the floor, it doesn't bounce open. And then I'm also going to drop it onto a towel so that it doesn't bounce as high. And that's mostly just to get a nice clean trace for the motion detector data. So I go ahead and hold this about 15 centimeters in front of the motion detector. I'll reach over and hit collect. And then I go ahead and drop. And the students see the graph in real time. So now that I've dropped both objects, I have a graph of position and velocity versus time for both of them overlaid. Because the velocity for the second object, the textbook, was quite a bit higher, what I'm going to do is use the auto scale feature up in the toolbar. So if I just click auto scale, that's going to reset the axes so that I can see all of my data on one graph. And if I want to zoom in on the area of interest, which is really just when I'm dropping the objects, I can just draw a box around it and then click on the magnifying glass with the plus, which is the zoom in option, which is again going to rescale the graph so I'm looking at just the area of interest. And in the lab activity, what we have the students do is compare the total displacement, which is the change in the position, to the changes in the velocity. And notice that they have very different characteristic shapes. The falling of the coffee filter showed a slow, steady increase in position, which is consistent with a near constant velocity, whereas the textbook had a very steep increase in position and a constantly increasing velocity, which shows that it was accelerating the whole time. So we can see from the graphs that the textbook falls much more quickly and that the coffee filter actually reached terminal velocity very quickly. And the differences there are primarily due to the difference in the air friction to weight ratio between the two objects.